All right, we're getting ready to start section 2.2 where we will be comparing sets, and I think in my 2.1 I was having a little trouble with my pen, and turns out the little battery on my pen died and I didn't even know it had a battery. Anyway, it's one of those batteries that's a AAAA, 4 A's, not double A, not triple A, 4 A's. You can't find those at Walgreens. I had to go to Best Buy where I got the pen. But anyway, I'm all ready to go now. Okay, here's the things we're going to cover. I'll let you read that at your leisure. And then moving on to the next slide, we'll start with set equality. Two sets A and B are equal if they have exactly the same members. So in example 1, A is the set of the numbers 2, 4, 6, and 8. And B is the set of numbers 8, 6, 4, and 2. Those are identical to 2, 4, 6, and 8, just in a different order. But they're the exact same elements. So you'll say that set A equals set B. And remember, sets are always identified by capital letters. And then example 2, C has 3, 5, 7, and 9, and D just has 3, 5, and 7. And since C has an extra number than 9, they're not equal. So that's all there is to equality. Hope that makes sense. And then moving on to the next slide. All right, subsets. Set A is a subset of another set B, if every element of A is also an element of B. And the symbol for subset is this symbol right here. It looks like a sideways U with a line underneath of it. So if every element in A, which A has a 2 and A also has a 4, and so when I look over to set B, B has a 2 and B has a 4. Every element of A is also in B. Now B has extra elements. It has this 8 and this 6, and that's okay. It's just every element in A must also be in B. And when they say that A is a subset of B, you've got this subset symbol here. Do you remember when you have, let me switch over to a pen, I'll go black. Remember when you have less than or equal to, it gives you an option, like you could say 2 is less than or equal to 4, but you could also say 2 is less than or equal to 2. So A could be a subset of B if B didn't even have these two. So if A was 2, 4 and B was 4, 2, not only are they equal, but you could say A is a subset of B because of the equal to part right here. They're a subset, actually, sorry, the equal to part's right there. It's the same concept. Hope that makes sense. And then in example 2, it says C is equal to 3 and 5, but D is equal to 5 and 7. Okay, so C has a 5 and D has a 5. However, C, use a different color, C has a 3. I don't see a 3 over here. So not every element in C is also in D. This 7 doesn't really matter. The 7 in there, it doesn't really matter. I'm looking for the 3. I have to have both a 3 and a 5 over here somewhere. I only have the 5. Every element of C must also be an element of D, and it's not. Only the 5 is. The 3 is not in there. So you would take your subset symbol and then just put a line through it so that you get, you know, is not equal to, or sorry, is not a subset of. Sorry, so you said is not equal to, is not a subset of. All right, now Venn diagrams and proper subsets. A Venn diagram basically is like a bunch of circles or ovals, and they put them inside of a rectangle or a square. You know, the rectangle represents the universal set, which means, and I think I explained that in the first section, it's all of the elements that you're going to consider for this particular problem. And the universal set can change from problem to problem. So set A is a proper subset of set B if A is a subset of B, but A does not equal B. So every subset can be a subset of itself. That's where the equal to part comes into play. But for a proper subset, they cannot be equal. So set A, let me go back to my pen, and it's a little bit thick. Let me make that a little thinner. There we go. And how about purple? So like if you had the elements of 2 and 4, and we'll call this set A, right? This is set A. And over here you have set B, which is just 2 and 4, then you would say A is not a proper subset of B. You could say A is a subset of B, but it's not a proper subset. To be a proper subset, and let me give you a different color here, B would have to have another number, like let's say 6. Now, A is a proper subset of B, and that's the symbol for proper subset. It's right here. You'll notice that the little equal to line, when we were doing subsets, it's this with an equal to line underneath of it. A proper subset is just that, without the equal to part underneath of it, because you're taking out the equal to part. So every element of A also has to be in B, but B has to be a little bit bigger. It's got to be bigger. And I'm going to stop my lecture right there because I think I'm running out of time. I'll have to do a part 2.